All right, let's look at the angle axioms. All right, first one, A1. So it says that for all angle A, B, C, there exists a unique measure called measure angle ABC between 0 and 180. All right, so this is basically telling you about the existence and the uniqueness of the measure. All right, and the next one, it says that if you have an interior point D of angle ABC, if and only if measure of the angle ABD plus measure of the angle DBC equal to measure of the angle ABC. So which basically tells you that if you have say angle ABC, so I'm gonna just draw angle ABC. Right, so here is say A, and this is say B, and this is C. Right, so if you have an interior point there, let's call it D. The ray BD is going to basically split the angle measure wise. So the sum of the measure of angle ABD, which is right here, and the sum of the measure of a DBC is going to be equal to the measure of the angle ABC. And this is if and only if, so it goes the other way around too. So if you have an interior point, the ray going through that interior point is going to basically split the measure into two parts. All right. A3. So A3 is basically an analogy to D4 in the distance axioms. All right. So let's look at that. So this is actually called the protractor postulate. So if you have a bunch of rays on one side of the line, then we can basically put a protractor on it. So that's basically what it says. So let's draw a picture. So it says that let's see, we can set up a coordinates on one side of AB. So let's say A is here, and B is here. Right, then basically we're going to be able to put a protractor, so kind of going like this. Right, then put a bunch of coordinates on it, and the coordinates are between 0 and 180. And for example, probably the coordinate around here is 90 and so on. Right, so it says that for all ray AX, so let's say you have a point, say X, say somewhere here. Then you're going to have associated, coordinate called X. All right, so number one is basically saying that if you have a ray, then you have a unique coordinate. All right. Part 2 says that if you have a number between 0 and 180, you can always find the corresponding unique ray AX. Right. Number 3, we set AB. So ray AB always have coordinate 0. Right. Then part 4, this is very similar to distance axiom. So let's say you have two rays, AC and AD. So I'm going to put, say, AC. Right, might look like this. And the coordinate is little c. Maybe I'll put C here. Right. And AD. So say D might look like this. So D is over here. So coordinate is little d. Then the measure of the angle here, CAD, measure of the angle CAD can be determined by the difference, positive difference between the coordinates. right? So that's what it says. So the measure here is determined by the positive difference between the coordinates. Right, A4, a linear pair of angles. Remember that the linear pair is just the, you have a common angle, a common side, and here, and the other two sides are opposite rays, right? Then if you have a linear pair, then it's supplementary. So let's say this angle is, let's say, angle 1 and 2. So if you have a linear pair, then measure of the angle 1 plus measure of the angle 2 is going to be equal to 180, right? So that's what the supplementary means, right? All right, so that's the angle axioms. Be sure to compare these to distance axioms. You can see the similarity. All right, that's it. I hope that this was clear.